Yes, thank you. So, self-signed, why not? Exploiting insecure certificate validation in iOS and macOS. But first, a little bit about me. So, my name is Aapo, work in cybersecurity in this Nordic cybersecurity company called Nixu. There I do IoT security assessments, cryptography, network protocols, and things like that. In addition, I do a lot of security research and bug bounty in different programs and mostly IoT and network application security. I coach this Finnish European Cybersecurity Challenge team, which is a CTF team, and last year we got first place in Nullcon CTF. But yeah. So topic today is TLS. And when you are using internet on your phones, there is you and there is something that you want. To get what you want, you have to connect to the internet. And the internet is this huge mess of computers trying to get you what you want. And of course, the internet is made up by different computers run by different people in different countries. So, of course, there are bad guys in the internet. And for that, people came up with this thing called transport layer security, so TLS for short. And what TLS does is creates an encrypted tunnel between the server you are connecting to and yourself. And this way, no one in the internet can hack you, or that's how it's supposed to be. So TLS is encryption and authentication between you and the server. The encryption part is this complex cryptography that many people have spent decades on perfecting, and it's called this military-grade encryption, that it's just bulletproof and you can't hack it. And for the most part, it's quite true. It's very hard to break TLS encryption. On the other hand, there is the second part, authentication. So to make a TLS tunnel between you and a server, the encryption part is quite easy. But the problem comes in that you have to authenticate the other party or the server. Because if you don't authenticate who you are connecting to, you don't know who have you done the encrypted connection with. So even if you have the best encryption, but you make the encryption between you and the attacker can send you whatever they want. And for that, there are these certificates. So a certificate is a text file that contains a signature. Inside the certificate, you have different fields, like the certificate is issued by someone and to someone. But in essence, it's just a fancy text file containing this information. So we can have a certificate issued by Aapo, issued to Aapo, with a public key, some miscellaneous information, like this is a certificate for Aapo, and a signature. And this is just kind of information inside a file. We need another file that contains the private key for our certificate. And how this works is that you have the public key inside your certificate, and with your private key, you can prove that you own the public key. So we have two files. We have aapo.pem and aapo.key. With a certificate, you can do a lot of things. For example, you can issue more certificates from the one that you have created. So you will have a certificate issued by Aapo, issued to Aapo. And then from that certificate, you can create more. So you can create a certificate issued to a server issued by Aapo. And how this works is that you calculate the signature to the file using your key. So your key is used to generate the signature that is stored in the file. And then for the server certificate, your original CA certificate calculates the signature and stores it into the file. To actually use the certificates, what you need to do is you need to store the original certificate to the device. However, you only need the public part. So you don't need the key anymore because the signatures have already been calculated. To the server, you store the server certificate and the server key. And with this, your device can check the authenticity of the server, and the server can prove that they are allowed to use the certificate. And of course, to validate the certificate, you need some code to run on your device. And that's called certificate validation. There have been multiple problems in certificate validation over the years. So during the past 15 years, quite a lot of problems. For example, during 2009-2012, Moxie Marlinspike released some tools at Black Hat and DEF CON that were used to intercept TLS connections and exploit vulnerabilities in the actual TLS libraries that were used at the time. There was also this problem with Apple's TLS implementation called the go-to-fail bug. And basically this allowed anyone to forge certificates for Apple servers or anything that the Apple computers were connecting to. And this was basically because the Apple code didn't check the certificate. So it didn't actually check properly whether the kind of signature had been calculated. After that, there have been some problems, even some recent ones, where the code run in iOS and macOS processing, kind of trying to verify the certificate, had a problem, and you could actually exploit the actual code trying to do the verification. But however, currently the libraries work quite well. So there are some problems, but not that much. But yeah, so we are not going to be talking about the actual TLS libraries that much here. There is a quite big problem in kind of how TLS works. Even like the TLS standard or kind of how all the libraries have been created. There is a really big problem that you can see already on this slide. And it is this, like the client can check the authenticity of the server. So why does it say can? And it is because certificate validation in TLS is completely optional. So all of the libraries allow you to disable the certificate validation. Kind of, in other words, to ensure that you are really connected to the correct server, you have to validate the server certificate if you want to. So this is kind of a major problem, that you want secure connections, like otherwise you wouldn't be using TLS. But if you don't check the server certificate, you have no idea who you are connecting to. So you are connecting securely to anyone. Thankfully, this is usually enabled by default. So certificate validation is usually enabled. But it can be turned off. And if something can be turned off, it definitely will be turned off by someone. And this is like if you go to Stack Overflow and you search for how to fix certificate validation problems, the first answer is turn off certificate validation. And the person who asked the question goes, thanks, it fixed my problem. And of course, you will not get errors if you don't do any checking. So attacks against certificate validation. So again, there's me, there's what I want, and there's someone in the between. So what you have to do is just generate a certificate and do a machine in the middle attack where you intercept the connection and just try to give the certificate. So how to do this? So what you do, you can use Linux command line tools, OpenSSL, to create you a certificate for the name Aapo. And then if you look at it, what did you create? We can see that we have a certificate that has an issuer, Aapo, subject, Aapo. So subject is who this is issued to. We have a public key, and we have some miscellaneous things. So this is just telling we have a CA certificate, so it should have more power. So it can create more certificates with it. And this is what we call a self-signed certificate. So you create a certificate for yourself, and then you can kind of use it for TLS and other things. Of course, it should not be trusted. It's just something that you created. With this certificate, we can kind of run Socket, which is a good tool to kind of listen to connections in different protocols and make connections to servers. And here, we can actually start a TLS server with aapo.pem and aapo.key that we just created. If someone tries to go to this website, for example, with curl, it will say that there is a certificate validation problem. It's a self-signed certificate, and it is not trusted. So we shouldn't connect to it. But like I said, it's super easy to just turn off certificate validation. For curl, you can use this flag insecure, and then it will just connect. So if someone is using curl with insecure flag, you can intercept all the connections. And this is something that I see as a professional penetration tester quite a lot. So just search for curl and insecure in the same line, and if you find it, there's a vulnerability. There is a shorthand for that, so it's this /k, and that's a little bit harder to find, but still, you can just grep for these. So yeah, it's quite easy to just do this. And this is something like everyone should have heard about this at some point. Like this shouldn't be anything new here yet. The problem comes when you are testing, for example, an iPhone. So you have the iPhone, it has a bunch of apps and libraries, and they are all connecting to somewhere. There happens to be something that they want. And the problem here is that you have so many different certificate validators inside the iPhone. So, for example, there can be hundreds of different certificate validators. So some of them might be running something like curl insecurely, and some of them might not. So we have to test everything to find out if kind of one phone is vulnerable to these exploits or not. And this is, of course, a lot harder. We can't just kind of generate certificates, intercept one connection, and do this. Or if we intercept all the connections, there is the problem that it just doesn't work anymore. So how do we actually do this? And for this, we need some automation. So if we want to automate certificate validation attacks, we have to kind of figure out that, like, because each connection, they might have a different certificate validator. So we need to figure out how to differentiate the connections. They might be connecting to the same server. So how can we actually know when it's a different connection than previously? And for that, we can use some kind of public data in TLS. So you have a client IP, server IP, kind of obviously, and then you have a TLS client hello. So how TLS works is that the client first sends these hello packets that I want to connect to you using TLS, and there's a lot of information that we can use. For example, the server name identifier tells us kind of, or the server, what host name do we want to connect to. So even though there's one server IP, there might be multiple hosts behind that. And if we go even further, we can check the different ciphers and extensions that the client wants, and we can see differences in those. So we can identify when this connection is a different one than we've previously seen. So if it wants different host name, then obviously it's a different connection. But if it wants the same host name, but it only accepts certain different ciphers, then we know that it's a different library or different implementation. So it's kind of a different connection. And for this, I created this tool called Certmitm, and you can automate certificate validation attacks with this. So if we have a phone and we are intercepting all the connections, we can see a connection to auth example. What Certmitm does, it kind of freezes the time at this point for the client, and then just starts to do different things. So first, we will connect to the real auth example, and we will download the server certificate for auth example. We will then generate certificates inside Certmitm, and then we will start to test these certificates that we've generated. And here, if we generate a self-signed certificate and try to give it to auth example, we can try to see if it accepts it or not. And in this case, it doesn't accept it, so we just have to let it go. So we will not be able to see the connection because it's a TLS connection between the client and auth example, and we couldn't intercept the authentication part, and we can't attack the encryption part, so we will have no idea what's happening there. Of course, we can see the host name and its auth examples. It's some kind of authentication connection, most probably made by an authentication library, and those libraries go through kind of a lot of testing, so they might be secure. But now that it has connected to auth example, it maybe kind of sends the password, gets a token, and then hands that token to a different part of the application. So, for example, it might then connect to API example. And then we do the same thing, try to offer a generated self-signed certificate. And what you know, we get a connection accepted, and it tries to post some payment information. And here we can see an authorization token. And if you know how this works, we don't need the kind of password anymore, because we can use this token to authenticate ourselves as the user to the API. So basically, we have stolen the credentials for this user, and in this example, they try to send $1,000 to Bob, so we could change this information, use the same credentials, and modify it. So what we do is we do a man-in-the-middle attack, and we have a connection between Certmitm and the client, and then we will create a connection between Certmitm and API example, and because we are connecting to both ends, we can actually see what is going on inside the connection. So if we forward this first request, because it tries it again, we can forward it to API example. And then it kind of connects again. It tries to get a software update, and the server returns a application as a software update. And of course, we could also exploit the client by tampering with this software update. And then if the client accepts our update file, we will get remote code execution. So, of course, I want to show you how this looks live. So here we have my machine. We have an iPhone on the right. So I have it right here. So it's just an ordinary iPhone. What we want to do first is we want to do the actual attack, or like the interception. So how this works is that I have a Wi-Fi access point connected to my computer. The iPhone is connected to the access point. And my laptop is acting as a router. So all the connections the iPhone is making are coming to my computer. And if I set up some IP tables, network bridges, and stuff like this, I can send connections from the iPhone to the internet. But if I see TLS connections, for example, if it tries to connect to port 443 in anything, then we will intercept that and send it to our machine to port 9900. And then we just need to figure out what to do in port 9900, and we can run Certmitm to listen on that port. So now, if there are any connections made by the iPhone, they should come to Certmitm, and Certmitm tries to do the things we previously said. So let's see. If we open, for example, App Store, we will start to see connections made by the iPhone to the internet, and we have tried to intercept them, but the interception was not done kind of correctly. The device wouldn't accept our certificate, and it says that the connection has been closed. We can, of course, retry, and then when we retry, the connections kind of are let through. And then we can see connection to apps.mzstatic.com, and we can still retry. So when we are looking for these vulnerabilities, we might need to retry the connections a couple of times manually, or if it's an application that runs in the background, we might need to wait for it to try it again. But this is, of course, only for looking for these vulnerabilities. So after we've retried a couple of times, we can then start to use the application. And we could try to download Snapchat. So how this works, it's kind of the App Store is connecting to different servers, kind of getting some information, and then kind of getting the actual URL for the packet it needs to download, and at some point it will try to download it. But when it connects to iOS apps.itunes.apple.com, it doesn't check the certificate. So we offered it a self-signed certificate, and we could intercept some data, and we can see that it's actually trying to download an IPA file from Apple. So here we have a certificate validation problem for Apple App Store on an iPhone. But Apple is very meticulous about this stuff, so I try to, of course, send a different IPA file, and I got really nowhere. So if I try to change things inside the connection, I couldn't get far. It checks that the correct software package was downloaded, and if it's not the correct one, it doesn't execute it. But we still get some impact because we can see what kind of packages the users are downloading and kind of how they are doing that. So if you don't want your kind of citizens or your employees downloading certain things, you can try to exploit this and see what they are doing. We can move on. So there was a problem, problems not only in the iOS operating systems, but also the applications made for iOS. So for example, Mattermost, I had a vulnerable version here, but they fixed it, so I can't run Mattermost anymore in the vulnerable version. So it auto-updates to a fixed version. Luckily, some stuff are vulnerable. So here is League of Legends Wild Rift game. And we can see some connections being intercepted. So it's trying to log in to the kind of servers. Let's see. So yeah, so we are here running League of Legends. And there are some vulnerable connections. Sometimes we might need to restart the application. It might not it might not work. They haven't done their error checking properly. So if some TLS connections fail, it might not just work. But yeah, so we can see more and more tests being done against this. And then if we try to kind of use it further, we might see some more vulnerabilities. So now it's trying to log in. We're intercepting some data, quite a lot of something. But here we can see, I think this is my credentials for Riot Games, so please don't steal my coins. Here's an authorization token that you can use to log in as me. And I reported this to Riot Games. But yeah, I will show their response in a second. Yeah, the red is really difficult to read, but I can try. So, yeah. But it says authorization bearer token. But yeah, so this was League of Legends on an iPhone. So yeah, so let's move on. So here we have this application called Books. It comes with iOS. And the difference between kind of normal apps and these iOS built-in apps is that the built-in applications have much more freedom to do things. For example, kind of background downloads and things like that. So here we can try to, let's remove this book and try to download it again. Let's see. So yeah, so if we try to download some books, the Books application doesn't check the server certificate. So here, similarly as the App Store, it tries to get this EPUB file from the internet, but it doesn't check the server certificate. And kind of a little bit differently from the App Store, because App Store downloads apps and then checks that they are actually the correct ones. But for these ebooks, it's a different story. So if we modify our setup a little bit, so if someone is trying to download books, we are actually redirecting them to our machine, and we will run this socket to listen for TLS connections, and then we just have a server running that distributes some ebooks. So if we now download the books from the books application, we will see maybe a connection made to us. Let's see. We might have to restart it. So let's see. Let's see what's happening. So it is doing something. Yeah. So of course it's not working. It's a little bit shy. Let's try once more. Might not actually be running. It is running. So let's just restart my setup. Download. Oh no. Yeah. No dice. So I might have to... Do I have a backup? Yes. So here we have the same setup. So if we remove the old download and then just re-download it, we will see that it makes a connection to our server hosting the books. And if we go to read the book, we will see this nice fellow has written something about the internet. And in the beginning, the internet was created. This has made a lot of people very angry and has been widely regarded as a bad move. And that was it. So, of course, that is not the original book. but a modified version from us. And if we can modify the contents of the book, we can of course try to attack the application further. And there was nice research just recently being done. I think at the same time I published this, or like reported this to Apple, they also reported a bug in the EBOB handling. So if we would have kind of known about each other, we could have made remote code execution through this attack. But yeah, so there's something wrong. Yes. But yeah, so that was the demo. And here are some Apple CVEs from me. So the CVE 2021 iOS App Store. So running, it was fixed in 14.5, and the impact was that the attacker can kind of see what books, what iOS apps are being downloaded to the iPhone. Then I've reported various bugs in iOS applications themselves. So with kind of varying impact, but in most cases I can take the victim account completely under my control. This League of Legends, Wild Rift, I reported it to Riot Games, and they stated that in theory it may be possible, but we would detect it and kick you or mark it as suspicious for investigations, and this finding will not be fixed since there is this kind of compensating control. So in essence, this means that if you hack someone with this attack, they will get banned. So you can't exploit it like. And for me, that doesn't make sense, but you can be the judge. I hope that this will get fixed at some point, but we will see. iOS books application, everything under 17.0 is vulnerable. There is no CVE number for this yet. I think it will be coming in a couple of days. So you're the first ones to hear that this application is vulnerable. And of course, macOS 14 is coming 26th, so in 2 days. You might want to update that also. Yes. The which one?
TLS version that you intercepted, is it specific to a version or all versions?
It's all versions.
Oh.
So all TLS versions are vulnerable to this because the authentication part has not been changed that much in different TLS versions. But yeah, so this is not just self-signed certificates. So my tool, it includes 4 different test cases. On top of self-signed, there are these different ones. You can watch my DEF CON talk to learn more about the different attack methods. And currently, there is Certmitm running, Certmitm Wi-Fi with password please hack me. I will do a small change here. So it should be now intercepting stuff. Yes. So if you want to find some 0 days, join Certmitm with the password please hack me. And if you click on some apps, they will appear here. And after the talk, we can see if we found anything. So if you're feeling lucky or just want to know, are you vulnerable to this, you can do it here. Of course, please don't put anything there that you don't want me to see. It's also not just Apple. So with Certmitm, I found approximately 100 vulnerable applications on iOS, macOS, Android, Windows, game consoles, IoT, whatever. From those, I think approximately 50 are kind of known 0 days to me. So there are no fixes For example, League of Legends for iOS, there is no fix. So that's a 0-day vulnerability. There are fixes coming in the coming weeks. And also there are more vulnerabilities found every week. Certmitm, I've made personally over $140,000 in bounties from these vulnerabilities. So this is a big thing. But what can you do? So if you're a penetration tester, bug bounty hunter, you should definitely watch my DEF CON talk about this. You should run Certmitm against everything and just make a profit. Why not? If you develop for iOS, macOS, or anything else, you really should read the documentation on how to use the TLS libraries or frameworks that you're using. You shouldn't do any custom certificate validators. Like, the built-in stuff works. It should support everything that you need. And if the built-in library doesn't support your use case, there might be a reason why it's not supported. It might be a really bad idea. So please stick to the kind of things provided by the libraries and read the documentation. Especially if you're using low-level TLS libraries, you might need to check the host name of the certificate kind of manually. This is something OpenSSL, WolfSSL don't do automatically, and it will lead to vulnerabilities. You can run some unit tests. So there is this self-signed.badssl.com that has a self-signed certificate on the web. And you can just write a unit test to connect to it. And if the connection goes through, then you should raise an alarm. And of course, running Certmitm against your products once they are in production is a really good idea. Couple words for Apple. So in 2012, there was this scientific publication titled "The Most Dangerous Code in the World: Validating SSL Certificates in Non-Browser Software." And non-browser software, for example, an iPhone. This was written 11 years ago, and they had some future research directions that someone should do. For example, someone should develop better black box testing code analysis tools for discovering errors in SSL connection establishment logic. So basically, Certmitm. And 11 years later, here we are. We have successfully kind of done the first part of the first bullet point. Of course, better white box code analysis methods should still be developed. So if someone turns off certificate validation, code analysis, static analysis tools should detect that. And some of them do, but not for everything. There should be kind of formal verification techniques, programming language support for automatically checking whether the applications actually use the libraries correctly. And this is basically what should happen, is that the developers should be warned if they misuse the libraries. So if you turn off certificate validation, you should get a warning during your build process. Or if you put a custom certificate validator, you should get a warning that points to some resource that, hey, this is not a good idea. And one thing Apple could do is just reject apps from the App Store if they have certificate validation disabled. So if they turn it into kind of development mode for development, it shouldn't go through to App Store without certificate validation. And the third point, and I think the most critical one, is to design better APIs for SSL and other secure network protocols. So when you are connecting securely to the internet, it should be kind of intuitive that it is like when you are doing it securely, and like if you're not doing it securely, it should be kind of obvious. Like curl, you have to write insecure. And if you have to write insecure, you know there might be a problem in your code. And of course, when you are doing development, you should have some kind of way to kind of maybe circumvent these, but you shouldn't be able to push that to production. So one idea would be to just have a overlay over the application that, hey, this application is using SSL insecurely. And like, this is okay for development use, but if you see this in production, then there's a problem. And this can be kind of combined with the previous point. And not allowing custom certificate validators. So kind of the APIs that you're using to call, make TLS connections, they should support everything you need. And you should kind of check that. And then you need to just educate the developers and enforce that they will not do TLS insecurely. With that, that's everything that I have for you today. Yes, so Certmitm, GitHub, Aapo Oksman, Certmitm, download it, use it, find some vulnerabilities and make the world a better place.